Hi, this video is the first of a series of videos related to Universal Law of Gravitation and how it correlates to circular motion and the kinematics of circular motion. So, what is the Universal Law of Gravitation? So, according to the Universal Law of Gravitation, as I am going to write the title first, Universal Law of Gravitation. Of gravitation. Okay. If we have two objects, let's say object A, and then I have another object, let's say object B, is object A and object B. So we have the first object, object A, and object B. And objects in the universe, according to a definition of matter, they would possess mass. So let's call this mass of 1, and this one is mass of 2. Mass of 1, mass of 2. So usually I would use uppercase to represent a smaller mass and uppercase M to represent a bigger mass. Or if those masses are the same, then just appoint which one is M and which one is M, which means lowercase m and lowercase or uppercase m. So these two objects are separated by a space, and that space, that distance between them, can be represented by the letter r. Okay. Now, let's remember that Universal Law of Gravitation. Okay. So force of gravity. So it's talking about force of gravity. So force of gravity is always attractive. It's always attractive, so it means these two objects is always attracting each other. So it's always attracting each other. And that attraction, so the magnitude of the attraction is the same. So you have the same Fg, or they're common. Okay, so it's common to both of them. So while A is attracting B, B is also attracting A. And that has something to do with Newton's third law of motion. For every action, there is an opposite reaction. So Fg and Fg, so they will be the same. So there's a common force that attracts each other. It's called force of gravity. Now, according to the Universal Law of Gravity, the equation can be represented by as follows. So Fg, which is the force of gravity, is equivalent to G, so multiplied by the product of the masses divided by the distance between those two objects. Or, originally it's written as Fg is directly proportional to the product of the mass and inversely proportional to the square of the distance. So what does it mean? Force of gravity becomes weaker when r, or distance, increases. Or Fg becomes weaker if or when masses decreases. The explanation is because the masses are in our numerator. So the bigger the number on the top, what will happen is that when the bigger the number on the top, Fg will become greater. While in the opposite, when you decrease the mass, since it's in the numerator, your Fg will become weaker. On the other side, okay, since the radius or the distance between those two bodies is in the denominator, So if you increase the denominator, what will happen with the value of your number will become less, or it will decreases or weaker, as it shows over here. Now, FG, here's the equation, very simple, where here's the corresponding designation. And you might be asking why FG or G is in this equation. G, because in mathematical equation, in order for you to take off the relationship, there should be a constant, and that constant is called the gravitational constant G, in order to make it work as a mathematical equation. So Fg is your force of gravity, or gravitational attraction, gravitational force. And the unit for force of gravity is in newtons. M is mass of letter A, or mass of B, and that should be in kilograms. And then lowercase m is mass of A, the smaller object, and that is in kilograms. R is the distance between them, and that is measured in terms of meters. And the last value that we must remember is your G, which is, and the value of this G is 6.67 times 10 to the negative 11. And that is Newton meters squared over kilograms squared. So this is basically what this law of the universal law of gravitation tells us. Okay. So now, in addition to the equation, let me go further. When does it become stronger? Fg becomes stronger when R decreases. Also, Fg becomes stronger when masses increases. So basically, the mass is directly proportional to your force of gravity, which means that you change the mass, increase the mass, your force of gravity will increase, while your radius, or the distance between the two bodies, is inversely proportional to your force of gravity. So this means that when you decrease it, or when you increase your distance, the force of gravity becomes smaller. The next video, you will see some application or some examples on how to use your force of gravity equation.